Hello campers, Dr. Dickey here. Okay campers, what's this video going to be about? This video's got a little bit of everything in it. It's got heartache, it's got jump scares, it of course always has hard work. That's always a part of it. And it's just kind of an update on things. It's a few things here, a few things there. So let's get into it. Sorry about that, the way I was speaking before. If you hear that kind of sibilance like that, it's because I had a problem with my bite and I had to have my teeth adjusted, as it sort of were, with braces. And so I'm supposed to wear these retainers now, and I had my retainers in. I took them out. So the heartbreak, we'll do that first. See that? See that beautiful solar array sitting there? Now it's only 6 panels, I know. 2 kilowatts of energy, I get it, but it's sitting there generating all that energy, and I can't use it. Why can't I use it? I can't use it because my batteries aren't done yet. That is the 14 packs, 160p, 14S 160p battery pack that I'm making of 18650 cells that's going to be charged up by this is not done, and until it's done I can't hook everything up. Of course I still need to run the trench all the way to the garage to run the 120 volts out, but I can do that. That's not going to be too bad. In the meantime, what have I done? Well, I took the two solar panels that were running my ham radio, 12 volt lead acid batteries, and I put them up on a 10-foot pole, hopefully to shade the shed that my battery everything is going to go into. You've seen inside the shed before. So they provide some shade on the side of the shed during the day, and that helps to keep it cool. I'll probably put something in those struts that are sticking out to shade the front, and I may run something from this shed over to the other shed to provide complete shade for this whole side, because I want to keep that shed down below 100 degrees Fahrenheit. That's the hope. So I promised jump scares. They're coming. Going to do a little bit of this, a little bit of that. I'm going to show how the batteries are welded up, and then I'll show why the batteries aren't being finished at this moment. Let's get into that. Okay, welding the packs. Basically, this is 28 gauge wire, and I'm going to put it from this side all the way to this side and weld in the cells. So let me get it tacked down on this end. It's a little bit more sparks than I wanted. There we go. That's tacked down there good. That's what you don't want. And I don't know why it does that, but it makes a nice little pit, and I don't want that. You don't want to make a pit like that. I don't know what causes that. It's obviously not getting a good connection, but I don't know. See, it doesn't seem to me to be any different than what I just did there. And yet, every once in a while it'll do that. And I really don't want it to do that at all. I wish I knew 100% what I was doing that was resulting in that, because that is exactly what you do not want. Last thing I'd want to do is poke a hole in the bottom of these things. So I don't know what caused that. It welded it, but I don't know what caused it to do that. It's obviously something I'm doing, but I'm not sure what it is. Maybe I wasn't on the wire good, but that doesn't explain why it does it on the positive, on the negative one. Usually it's the negative one that does it. All I know is I don't like it. I don't like it at all. And now they're all soldered up. Again, not the prettiest soldering in the world, but it's functional. I got to where those wires are connected with very, very good connections. Um, the solder flowed on the copper. Copper was clean with the flux. Now I just have to clean off the flux. So, one more pack to do, and then tomorrow I start hooking up the positive side, making them into actual big batteries. Getting close. Just a quick update. I have mounted 2 solar panels on top of the shed to serve 2 purposes. One is to charge a battery that will be inside the shed to run a fan that will cool the shed down. Secondly, to shade the top of the shed to keep it cooler. That was quite a task to do by myself. First putting up the struts and then getting the solar panels up there the way I wanted them so they don't shade each other. Do get a little shade from my neighbor's bamboo, but that is what it is. So I'm going to find out, make sure so that they don't leak. I bolted right through the rubber top and actually could screw the bolts down through the rubber, so I'm pretty sure they're sealed, plus I put some caulking on them to try and seal them up as well, but I'm pretty sure they're sealed. They should be pretty watertight. And I get sun on those solar panels till maybe 1 o'clock in the afternoon, which should be fine, because then when the shade starts coming over for the shed, it's going to be cooling the shed down anyway. And so I'm going to put a battery in there. I think I want to run those parallel rather than series and do a 12-volt system in there, because one of the lower panels does get some shading from the bamboo a little bit earlier than 1 o'clock. And of course, if you have them in series and one panel gets partially shaded, it really shuts down the entire operation. Whereas if they're in parallel and one of them gets shaded, the other one can still put out full voltage and amperage, and so can still do some charging and run the fan. But they should run the fan during the hottest part of the day, and then the battery will pick up any slack otherwise. Hopefully their shading is enough to really help the process. That's what I did last day or two. I'm also putting the ground rod in over here for the solar system. I got to finish pounding that in and then running that into there. But that's where we stand right now. Now I've got to get doing more work. Well, I'll show you my setup that I'm going to try. Okay, this is my planned layout for what's going to go above the battery. The large circuit breaker that you see there in the center, that has a 24-volt trip on it, which I can hook up to the Batrium, and if the Batrium gives me a critical fault, it will trip that circuit breaker and take the battery out of the system and pretty much shut everything down. I've got 2 bus bars for the positive and negative. There's my inverter, breaker coming out of the inverter, breaker going into the inverter. This is my solar charge controller. It's a Midnight 5150. I've got a breaker for where the PV voltage is going to come in, go into it, and then a breaker where it comes out before it goes to the bus bars. And then of course there is the shunt for the Malectrics system. That's the plan right now. I'm going to wire everything up. I just got my wire in, my 4-gauge wire. I'm going to wire everything up and then take off the inverter, take off the solar charge controller, take off the circuit breaker, mount it, and then put those back on. So I've marked out about 7/8 of an inch out from the plywood, and I got to be a little bit outside of that. That'll give me enough room to be able to screw in the connection when it comes in. I'm going to use one of these step drill bits, which I'm not a big fan of, but everybody seems to use them to try and drill that out. Let me see if I can do this where you can actually see somewhat of what I'm doing. Got that drilled out. Nice fit. And of course the lockdown ring. Again, I'm not a fan of those step drill bits, but I have to say, this one actually did a decent job. Just run those there. And now, I need to drill a hole through the shed to put it through. Alright, I had to take the PVC and heat it up and bend it a little bit to get it to go nicely. But it finally went nicely. And so I have it now going to the outside of the shed. There's where it comes in on the inside. And there's where it comes to the outside. So I'm going to put it down from there and then dig my trench over and run my wires as I'm digging my trench. So I know what you're saying. You're saying, oh my, that's a heck of a turn there. Why does it have to come out so far to do a turn like that? Well, it's kind of got to do that because with these wires you can't do sharp 90-degree bends. You have to do gentle ones. And so that's just the way it's going to have to be. I'm running the wires now, pulling them through, and then finish digging my trench to run them over to the combiner. This is 6-gauge wire. And the reason it's 6-gauge here, even though it's 10-gauge coming from the solar panels, is each solar panel puts out about 11 amps, just under 11 amps. And I'm combining them, 2 in series, 3 in parallel. So it's going to go from 10 amps about to 30 some amps, and then it's a little bit longer run. So I'm using 6-gauge wire going into my setup, going to the solar charge controller. Let's try to pull some more of this. Alright, I have to bury it, but it's sealed. It's glued from inside the box. Well, you don't glue it inside the box, to inside the box over here. I'll show you. So now all I have to do is wire it in. Holy moly. That broke my cutters. Obviously, those were not the right cutters. I use those usually for just peeling back the insulation. These are the correct cutters, or should be. This may be even big for these, but I think I'll do okay, yeah. That's still a little bit long. You can always cut twice, but you usually can't add any on, so. Okay. I'm sure they probably sell strippers for 6-gauge wire, but I don't have any. So I just do it this way. What I consider to be the old-fashioned way. Okay. And then torque that down to 20 inch-pounds. The old torquing tool. There we go. It's at 20 inch-pounds. Now for the negative. I'm going to run the negative all the way up to this because you want to keep your, again, I like to keep my lines about the same distance. Now, of course, we're talking about inches difference, which really doesn't make a difference, but as long as I'm going to do it, I might as well try and do it the way I want to do it. This one in. In there. And put it down to 20 inch-pounds. There we go. And before we button this up, we have one more to do. If you remember where I had a 7-foot copper rod that I pounded into the ground, and that is the 7-foot copper rod right there, believe it or not. It is 7 feet into the ground. To that, we are going to hook some, I believe this is 4-gauge copper wire. Ran out of battery and it shut down on me. Let's see if I got enough time to do this. Then I'll have to bend that around. All right, that's all buttoned up. I just gotta like zip tie this down. And now I just have to hook it up inside and then I can test everything and make sure it's okay. So I know what you're saying. You're saying, wait, Dr. D, didn't you tell me that the wire you put inside here is 4-gauge and this is 6-gauge? Why, if you have 6-gauge coming in, why do you need 4-gauge inside? Well, from each panel, it's 10-gauge. Each panel has about 10 amps coming through. About 40 volts, 10 amps. But then I combine them and I put them in series. Series doesn't change the amperage, just the voltage. Voltage goes up to about 75 volts. And the amp stays around 10 amps or so, 9 to 10 amps. But then I combine them. And when I do 3 parallel in the combiner box we just did, now it's up to about 30 amps. So coming into here, that's why I went from 10-gauge going from each panel to 6-gauge going from the combiner box to here. This is an MPPT, I think that's multi-point power tracking solar charge controller, which means if what I've been told is correct and what I've heard is correct, that means that it can technically take the 75 volts that are coming in, and because it runs 48 volts out, it can take the increased voltage and turn it into increased amperage. So even though there's only about a little less than 30 amps coming in, it could have it go up to a higher number of amps, and therefore I went from the 6 to the 4 in here, and then going out on the 120 from the inverter, coming out from the inverter, of course, that's going to be 120 volts, so I'll drop it back down to 10-gauge wire to do my run into the garage. That's the reason for that. Now let's get this circuit breaker hooked up and get this all installed. Okay, so it's time to answer the question. I got all of the negative bus bars and all the wires welded on all 14 packs. Here, I'll show you. This camera's not so great for close-up, so I don't know how well you'll be able to see that, but you can see I've got them welded and soldered, my wires, 28 gauge wire, on all of the negative sides. And I got that done on all 14 packs. So if I got that done, why haven't I finished making the packs up? Because I have to get the battery put into this system before I can really start doing anything. Well, the reason is because of what I thought that I didn't bother to check until it came time to do it. And that is the 2 amp axial glass fast blow fuses I was going to use. Let me show you. So the idea was to use these fuses and to put them between the cells and the bus bar, weld on the fuses just like I welded on before, and then solder them to the bus bar. The problem is the glass portion of these fuses is so long that really it becomes unrealistic to try to fit all these things in here, because I have to weld and they'd have to come over, and it just was not going to be feasible to then have fuses going that direction. And then how am I supposed to get a fuse going this direction where I have to weld it down to the pack and weld it onto the bus bar? And so I'd have to go at this angle, at that angle, at this angle, and then I'm going to have to put another one there and another one there, and one here and one here. There just wasn't going to be enough room. I could probably do it, but it was going to be very sloppy, and it was going to be very, it wasn't going to be very good. So rather than using these 2 amp fuses, I decided, partially based on Pete's video from HP Powerwall down in Australia, that he uses 32 gauge tinned copper wire. Now, I used 28 gauge tinned copper wire on the other side. He wanted to use 32 gauge tinned copper wire. That's what he uses for his fuse system. That's what I was going to use, because then I could just weld them in just like I did for the 28 gauge on the other side. So I had to order some. Yesterday, 32 gauge tinned copper wire finally came in. So I'm going to do it the same way I did it on the negative side, only I'm going to use this thinner. And this will blow at around 10 amps, which is perfectly fine, because these cells are capable of output of 10 amps max, but I'm not fusing them for their output. I'm fusing them in case one of the cells shorts out, and the whole back dumps the whole pack, the other 160 cells, dumps all their energy into that cell. It'll be a lot more than 10 amps, and that will blow and protect the cells from over-discharging and shorting out and catching on fire is the biggest thing. And I'll show you that is about 10 amps. Okay, I'm going to try and hook this up so you can see what's going on. This is a DC power supply. It gets up to 10 amps. That's all it does, which is fine. Let me cut off a piece of my wire. Now, the length of the wire makes a difference, because the longer the piece of wire is, the greater the resistance, and so therefore it's going to blow at a lower amount of amps because it's going to have more resistance. So I don't think I can make this wire as small as it probably will be when I put it in, but it will be representative. So let me hook this thing up, and right now I think it's got about 4 amps going through it. Make sure you can see this. 4 amps going through it. So now it can handle 4 amps all day long. If I go up to about 5 amps, no problem. It can sit there. There's no visible signs of anything. Go up to about 6 amps. Again, no problem. Everything seems to be fine. 7.5 amps, still doing okay. 8 amps, still looks okay. 9 amps, still don't see any visible signs of any problem. 9.5 amps. Now you can just barely see it starting to glow a little bit red. I don't know if you can see that or not. 9.5, 9.6, now 9.8, it's really starting to glow. Now we get up to 10 amps. 10 amps and it's glowing pretty good, and it's going to burn out here in just a second. But it can even stay with 10 amps pretty well. 10.25 amps, and boom, it finally blows in half. Again, it will be about that distance. It may be a shorter run, slightly shorter run than that, so it may take more amps. I would figure it will probably blow around 12 to 15 amps at the most, maximum, which is fine because the idea is to keep it, to make it blow if one of the cells shorts out and the pack is dumping all of its energy into that cell because it's got a dead short or it's shorting out. And so I think that 32 gauge wire will work fine. All right, thanks. So I've now can start putting together the packs. I'll come back when I get and make another video in a couple of weeks when I have all the packs welded up with their fuse wires and turned into packs, and then I'll probably do some capacity testing on them, so I'll show you all that. In the meantime, I'll be digging the ditch that will run my 120 volt 6 gauge conductor wire to the garage from the shed in preparation for the panel being put in and finally getting things going off grid for a portion of our house. Thanks. See you next time.